Hello class and welcome to lesson 4.5 logarithms. This is one tool that we can use to solve exponential equations if we don't have a graph or if it's uncommon to find bases that are like or common bases. All right, so what we're going to reintroduce here, folks, is something we've been teaching since grade 8, maybe grade 9, is when solving we talk about opposite operations. So for example, say you've got an expression 3x equals 12. Currently, the x is times by 3, but in order to solve for x, you do the opposite operation, which is divide by 3. And in this case, you would get x equals 4. Okay? Again, you could take a look at the opposite. Adding is the opposite of subtracting. So if I had x minus 2 equals 8, you would, to get x by itself, add both sides, 2 to both sides, so it would be 8 plus 2. So in this case, x would equal 10. We also want to remember, folks, that the opposite of squaring is square rooting. Okay, so if I had x squared equals 16, and you wanted to get the value of x equals the square root of 16. So in this case, x equals 4. Now, these opposite operations can occur also in exponential functions. So write this down, please, folks. The opposite of an exponential function is the logarithmic function. Okay? The inverse, which is what it is, the inverse is the same as the opposite of an exponential function, is a logarithmic function. A logarithmic function is so important that your calculator actually gives it its own button. And the own button says log. So look on your calculator, ladies and gentlemen, for a button that says L-O-G. Okay, that means logarithm. Okay? So if we take a look, ladies and gentlemen, on this graph, if I had, for example, an exponential expression, which is y equals 2 to the x, and I take the inverse of it, i.e. I switch my x with my y, I put it in what's called logarithmic notation, so it's going to be y equals log 2 of x. Okay, now we're going to be interchanging back and forth here with these expressions. So let's just quickly revisit some formulas here. So we know the exponential function is y equals b to the x. And in this case, y is your product, b is your base, and x is your exponent. When we get into logarithmic forms, ladies and gentlemen, things change a bit. Okay? Although it says y equals log b to the x, the y in fact is an exponent, the log of the b the base, and x is your product. So just remember, when you do what's called the inverse, you switch the x and the y. Okay, so that's why these get switched in these expressions. Okay, that's what this statement says right here, guys. Be careful of the variables. They are not representing the same thing in each equation, but it's how they are written in the textbook. So we need to take a look at some examples of this, okay, in a little more detail. So in exponential form, ladies and gentlemen, the y is the product, the b is the base, and the x is the exponent. Okay, so if I write down an example, 9 equals 3 to the power of 2. Okay, just remember that 9 is what we call my product, 3 is my base, and 2 is my exponent. Okay, when we look at logarithmic form, ladies and gentlemen, just remember that we've switched the x's and the y's. So in logarithmic form, it looks a little different. Y in this case is the exponent, b is your base, and x in this case is the product. Okay, so if I was to write this in logarithmic form, I would say that 2, which is my exponent, equals log 3 of 9. Okay, and that's logarithmic form. A third way, ladies and gentlemen, to get to solve using this is the log of the product divided by the log of the base. So if I take my initial expression, 9 equals 3 to the power of 2, and I apply the log to the left side, so it's going to be log 9, and I apply the log to the right side, it's going to be log 3 raised to the base of 2. Now, in nature, the logarithms, when you put them in this form, ladies and gentlemen, this allows you to take the exponent and bring it out front. So I'm just going to leave this as log 9 on the left side. On the right side, I'm going to bring the log exponent out front, because that's what you can do with logarithms. Okay. And then if I wanted to get the exponent by itself, I'm going to leave 2 there. I'm going to divide both sides by log 9, or sorry, log 3, my fault. So what does that equal, ladies and gentlemen? I'm just going to, fix this up a bit. If I have my exponent here, 2 equals log 9 over log 3. And again, what does this represent? Log of the product over log of the base equals my exponent. All right. Second page, ladies and gentlemen, remember it's asking us to write it in logarithmic form. So just remember that the y is your exponent and the x is your product. Okay, so to rearrange this, ladies and gentlemen, we start with our exponent. So it's going to be 3 equals log of what's my base? 6, bless you, of 216, which is your product. Okay, try the next one. Our exponent here is 2 equals the log of what's our base of that exponent? It's 5 of the product, which is 25. Let's try the last one. 5 is our exponent equals log of 2, log 2 of 32. And ladies and gentlemen, it doesn't matter if when you take a look at your question, for example, B, you've got the exponent exponential form equaling a product, or C, a product equaling the exponent. Just remember, left side equals right side, so right side equals left side. Alternatively, you could have written this log 6 to 16 equals 3, and that would also be correct as well. All right, so let's take a look at rewriting in exponential form. Okay, so all we have to do is remember that when we've got exponential form, the y is the product and the x is the exponent. They're switched from the last one. Okay, so first of all, what are we going to start with? We could start with 64. Okay, so you could say 64, that's my product, equals my base, which is 8, raised to my exponent 2. Or, ladies and gentlemen, if you wanted to do it the other way, you could say 8 squared equals 64, because left side equals right side, so right side equals left side. All right, taking a look at the second example, my product is 625. That's going to equal my base 4 raised to my exponent, my base 5 raised to my exponent 4. And looking here, we've got our base of 49. That equals, my product of 49, I apologize. Product of 49 equals my base 7 raised to the exponent of 2. Okay, we're almost done here, folks. Use your log button to determine the exponent. Again, look on your calculator. You have log button. All right. So, ladies and gentlemen, last day we learned to take an expression and make sure we've got the same basis. You can do that. However, this is pretty hard to figure out what 262,144 is exponent rate 4 raised to an exponent. So what we want to just do is do the logarithms of the product divided by the log of the base. So log of 262,144 divided by log of the base, which is 4, equals x. Plug it in your calculator and you should get 9 equals x. And I just like to have it x equals 9, always have the variable first. Okay? Try the second example. If I want the variable first, I could just go like this. X equals the log of the product, which is 3,125, divided by the log of your base, which is 5. Plug it in your calculator and you're going to get 5. What does that mean? That means that 5x to the raised to the exponent 5 equals 3,125. One more here, folks. Okay, x equals the log of our product, which is 1296, divided by the log of our base, which is 6. So x equals 4, plugging in your calcs. All right, last thing we're going to mention, ladies and gentlemen, before we get done here, is that logs with base of 10 are what we call common logarithms, and they don't write the 10. So for example, log of 1,000 equals 3 really means log 10 of 1,000. Okay? Just want to make sure you realize that 10 is the base here, and that's the same here. So this has got a base of 10. So if they don't tell you, it's base 10 for sure. All right. Okay. What does that really mean, guys? Is that um, a box raised to the exponent 3 equals 1,000. So what is my base? That is 10. All right. Hey, DT, how you doing? You gonna do some videos with me? No? Okay. No, we still don't have DT doing videos. We'll get him to do math. Okay, so ladies and gentlemen, just a final recap here. I just thought I'd show you a little graphic of 2 to the power exponent 3 equaling 8 and how you change it to logarithms. And I want to show you a quick video on, hopefully this works. Let's see if it'll link up. Okay, quick video on logarithms, and then we're done for the day. All right, ladies and gentlemen, the log doesn't seem to be working. So let me just see if I can post the link here for you. Okay. Maybe it is working here. Okay, this is a new thing for me to show. So sorry, we got 2 running here. Let me start that again, guys. Sorry, here we go. You want to learn it? It sounds good. All right. I'll be with you. Any questions? That's very good. That is not good. That's where it says. Oh, okay. I gotta cut that myself. So. Okay, ladies and gentlemen, sorry I forgot the video was over. If the sound did not work on that video, please YouTube at the following address. Okay, let's go back to logarithms here. Your homework is page 75 to 76, numbers 1A, B, C, D, 3A, B, C, D, 4, 7, 8A, B, C, 10, and 12. Have a great day, folks, and see me if you need any help.